Okay, hello everyone, welcome to the OneClass channel. My name is Andrew and I'm currently doing Stat and Math at University of Toronto. And today we'll be going over some commonly asked math questions at both the high school and college levels. If you need some homework help or tutoring, please check out the link in the description below. So now let's start our session. Okay. Okay, let me just zoom in a bit. Okay, so the first question is asking us what is the Leibniz notation? Okay, so let's write that down here. So what is Leibniz notation? Okay, so in calculus, Leibniz notation, named in honor of the 17th century German philosopher and mathematician, and use a symbol, let's write the keyword down. So use the symbol dy and dx to represent the infinitesimal increments in the values of x and y respectively. Okay, so dy over dx is equal to delta x over delta y. And when we use the notation dy dx, we see that we take the derivative of y with respect to to x. So dy dx, this is literally means we take the derivative of y with respect to x. Okay? Oh, and same thing. If we have dx over dy, then it's going to be take the derivative of x with respect to y. Okay? So that's sort of like a definition of what that is. And then let's try with a couple examples. So let's see, we have dy dx of x squared, and this is going to just be equal to 2x. Okay, and this is just literally means the derivative of x squared is 2x. Okay, so let's try one more. Let's say dy dx 3x plus e to the exponent of x, and this is just gonna be equal to 3 plus e to the exponent of x. Okay, so this means the derivative of 3x plus e to the exponent of x is 3 plus e to the exponent of x, right? Because recall the derivative of 3x is just 3, and the derivative of e to the exponent of x is just itself. Okay, I think that's all we got for this question. Let's leave a comment. Solution is correct. Okay, so our next question. Let's copy down the question first. It's asking us what are the angles? What are the angles of a 5, 12, 13 triangle? Okay, so first we need to know that the 5, 12, 13 is just the length of the triangle, and where 13 will be the hypotenuse, and 12 is a long leg, and 5 is a short leg. Okay, so given the three sides of the triangle, we can solve the angles using the cosine law. So let's write it here. So first, cosine law, which is given by 3 squared, c squared is equal to a squared plus b squared minus 2 times a times b times cosine c. Okay, where ABC are the side of the triangle and C is the angle opposite side C. I'll just write it down here. So ABC are the sides of the triangle. Well, big C is the angle opposite to side C. That should be small c. Okay. All right. So now we can sketch the given triangle, right? Okay. So we have triangle with 12, 13, and 5. Oops. Okay. So we have short leg A is equal to 5, and B is 12, C is 13, and the corresponding angle that will be A and B and C. Okay. So that's what the triangles looks like. And in order to solve for C, we just need to substitute the number in. Okay. So let's write it down here. So solving for C. Okay. So C squared is equal to A squared plus B squared minus 2AB cosine C. Okay, and then we just substitute the number in. So we know C is equal to 13 and B is equal to 12 and A is just equal to 5, right? So let's substitute those numbers in. So we got 13 squared is equal to 5 squared plus 12 squared minus 2 times 5 times 12 times cosine C. Okay, and 13 squared just equal to 169, and 5 times 5 is equal to 25. 12 times 12 is equal to 144. Yeah. And then 2 times 5 times 12 is equal to 2 times 8 is equal to 120. Yep. So times cosine C. And then let's just keep doing the calculation. So we will have 6, oops. If there's some technical issues with my iPad again, just give me a second. Okay, it's good now. So 169 is equal to 25 plus 144, which is 169 minus 120 times cosine C. Okay, so now we just minus 169 for both sides. So we got 169 minus 169 is equal to 169 minus 120 cosine C minus 169, and 169 are cancelled out, so we will have 0 is equal to negative 120 cosine C, right? And we're just dividing both sides of the equation by negative 120. That will give us 0 is equal to cosine C. Okay, and getting the inverse cosine of both sides of equation, we will have cosine inverse 0 is equal to C cosine is equal to C, right? So C is just equal to 90 degrees. And since C is 90 degrees, so we conclude that triangle ABC is a right triangle. Okay, so go back to our diagram. C will be 90 degrees right here. Okay, and the reason why we want C to be 90 degrees is that if C is 90 degrees, we can apply the trigonometries. Like we can apply the sine, cosine, and tangent into this particular question. Okay, so by knowing that it's 90 degrees, we can use the cosine law. Okay, let me change the color. Okay, so now we figured out the angle for C. Then let's do solve. Then let's solve for angle A. Okay, so before we solve for angle A, let's just review what a sine law is. Okay. So sine law, and that is given by sine A over A is equal to sine B over B, and is equal to sine C over C. Okay, so to solve for angle A, we have sine A over A is equal to sine C over C, right? And that is from the sine law property. And then we can substitute the value for A and C, which is sine A is equal to 5. And sine C, we know C is 90 degrees, so sine 90 over C, where C is a hypotenuse, which is 13 in this question. And I'm gonna do this by cross multiplying. Okay, so we will have 13 times sine A is equal to 5 times sine 90. Okay, and since we only want A on one side, so we'll move 13 to our right hand side. So 5 times sine 90 over 13. And sine A is equal to, because sine 90 is just equal to 1. Okay, so 5 times 1 over 13. And sine A is just equal to 5 over 13. And getting the inverse sine of both sides of the equation. So we will have A is equal to sine inverse 5 over 13. And you plug that into your calculator. So that should give you 22.62 degrees. Okay. Yep. So that's what we have for the angle A. And lastly, we need to solve for the remaining angle B. Okay, let's solve for angle B. And there are several ways of doing that. You can either approach it with Sine Law. Let me just write it down here. So you can just either do it by using Sine Law, which is what we use for the angle A part. Or you can do it the Cosine Law way, which we use for solving for angle C. Or you can just use a definition of the sum of interangles. So definition of interangles for triangle. Okay, and I found that the third way is the most easiest. So let's use this one. So A plus B plus C is equal to 180 because it's sum of the interangles of a triangle is 180, and applying what we have, so we know A is equal to SA is equal to 22.62, C is equal to 90. So we have 22.62 plus B plus 90 is equal to 180. And that's gonna be 112.62 degrees plus B is equal to 180. And then we minus 112.62 on both sides. So we will have 67.38. Okay. Yep. So now we have all three angles, and we can write our conclusion. Therefore, the angles of a 5, 12, 13 triangle are 22.62, 67.38 degrees, and 90 degrees. Okay. Yep. So I think that's all we got for this question. Yep. Okay, so now let's leave a comment there. The junior tutor's answer is almost 100% correct, just except for this part, because 2 times 5 times 12 should be 120 instead of 60. So, but other than that, it's all it's all correct. And also, because it's gonna divide both sides by the equation of the equation by negative 120, so that doesn't really affect our answers. Yep, but our other part are correct. Solution is correct. Is almost all correct, except for 5 times 12. Let's see what that again. 2 times 5 times 12. Is equal to okay. So the next one is asking us how to graph the line x equal to 0. Okay. So graph x equal to 0. Okay, so first let's draw xy axis. Okay, so that's y axis. This axis, that's 0, that's 1, 2, 1, 2, negative 1, negative 2, negative 1, negative 2. Alright. So the equation x equal to 0, it just means that the value of x is constant, and for any y value, the x value remains the same. Thus, we graphed the line is a vertical line at x equal to 0, which is actually the y-axis. Okay, so yeah, so it just should be right here, and that is x equal to 0. Okay, so same thing, if it's asking where is x equal to 2, it should be right here. Because when you look at the point of this vertical line, it's just gonna be 2, negative 1, here 2, negative 2, 2, 1, 2, 2. Yeah. So no matter what y values we have, the x value always remains the same. And same thing for the x equal to 0. So that's 0, 2, 0, negative 2, 0, negative 1, and 0, 1, and 0, 2, right? And as long as x is equal to something, it's always going to be a vertical line. And on the contrary, if it's y equal to something, it's always going to be a horizontal line. Okay, so let's just use this as an example. So here, if here's let's say 3 and 4, so that's y is equal to 4. Okay, so as long if it is y is equal to a constant, that's going to be a horizontal line. Okay, yep. So in this case, the x equal to 0 is just actually our y-axis. Okay, so let's leave a comment. Solution is correct. Okay, so for our last question today, we just need to factor x cubed minus 27. And before getting into this question, I would first like to recall the special factoring formula, which is given by a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. Okay, so now we just need to let a is equal to 2x, since 2x cubed is equal to 8x cubed, and I write it in here. So 2x cubed is going to be x equal to 8x cubed, and I'm gonna let b is equal to 3, because 3 cube is just gonna equal to 27. So we have 2x cubed minus 3 cubed is equal to 2x minus 3 times 2x squared plus 2x times 3 plus 3 squared. Okay, so that is gonna be equal to 2x minus 3 times 4x squared plus 6x plus 9. Okay, yep, and that is our final answer. So let's leave a comment. Good. Yeah, so I think that's all we have for today. And if you enjoyed today's Q&A and would like to be notified of when we do this next, please hit the subscribe button or notification bell below. And if you would like to submit your own questions, please visit the link in the description. Remember to leave a like and a comment and share this video with your friend. And this has been Andrew from